Question number 2 says that find the area of a quadrilateral ABCD whose four sides have been given as AB equals 3 centimeters, BC equals 4 centimeters, CD equals 4 centimeters, and DA equals 5 centimeters. And one of its diagonals, AC, is equal to 5 centimeters. So let's first draw the required quadrilateral. The area of this quadrilateral can be found by finding the area of triangle ABC and the area of triangle ADC. And then we can add it up to get the area of quadrilateral ABCD. So let's first focus on to the triangle ABC. Here we can observe that the three side lengths are in the form of Pythagorean triplet. By that we mean that if you square the length of AB and the length of BC and add it up, that will be equal to the square of the length AC, which is 5 centimeters square. So that means triangle ABC is a right angled triangle, right angled at B. So we can take AB to be the base while BC being its respective height for triangle ABC. So the area of triangle ABC can be found by making use of the formula half into base into height. So let's substitute these values. We get 1 by 2 times 3 centimeters times 4 centimeters. That on further calculation gives us that the area of triangle ABC equals 6 centimeters square. Now the next part is to find the area of triangle ADC. But here we see that they have not given us the height. So the formula that we can make use of is Heron's formula. So let's write that. Heron's formula says that the area A of any given triangle equals under root S times S minus A times S minus B times S minus C, where S is the semiperimeter of the triangle and ABC are its three side lengths. So for triangle ADC, we will first have to find the semiperimeter, which can be found by adding up its three sides and dividing it by 2. So let's start adding 5 centimeters plus 5 centimeters plus 4 centimeters, and let's divide that by 2. So that gives us 14 centimeters by 2. So we can say that the semiperimeter S for triangle ADC equals 7 centimeters. Now that we have found the value of semiperimeter, we can substitute these values back in Heron's formula. So let's do that. So by Heron's formula, we can say that the area of triangle ADC will be equal to under root 7 times 7 minus 5 times 7 minus 5 times 7 minus 4 centimeter square. That on further calculation gives us under 7 times 2 times 2 times 3 centimeter square. So that comes as 2 times under root 21 centimeter square. So that is approximately equal to 9.166 centimeter square. Now that we have found out the areas of both the triangles, let's add them up. So now we can say that the area of quadrilateral ABCD is equal to the area of triangle ABC plus the area of triangle ADC. As we know these values, let's substitute them in. So we write 6 plus 9.166 centimeter square. So that comes as 15.166 centimeter square, which is approximately equal to 15.2 centimeters square, and that is the area of the quadrilateral ABCD.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.